Hedgie's Corner, we're going to look at solving logarithmic equations and inequalities. So let's start with some solving. Number one, remember we have the 9 as our base, right? Log base 9 of x is equal to 3 over 2. Okay, so we're actually going to make sure our x is always on the left-hand side. Not that it really matters for equations, but it's definitely helpful for inequalities. So we're just going to get into that habit. X is equal to, our base is 9, and our exponent is 3 over 2. Let's make that 9 3 squared, and then we'll raise that to the 3 over 2 power. So that ends up with x is equal to 3 to the third power, so x is equal to 27. All right, let's look at the next one. This time our x is our base. So we're going to have x, and remember our exponent is always our answer in a log problem, is equal to 16. Okay, let's get that 16 a little bit easier to work with. So we'll make that 2 to the fourth. Now on the x on the left-hand side, we need to raise that to the 3/4 power. We're going to do whatever we do the left, we have to do the right-hand side, right? So that gives us x to the first, which is what I want. And then I have 2. Now this is over 1, so this is all going to cancel. So I get 2 to the third, so x is equal to 8. All right, now we're going to get a little bit more advanced. Now remember from previous lessons that we know that b here, our base, and our argument there has to be positive numbers. And b can't be 1. It can be a positive fraction, but we can't have 0, but they have to be positive. Okay, so if we look at our examples here, if we have the base the same, I can kind of make our argument set equal to each other and go from there. Okay, so let's look at number 3. Our log, our bases are the same, and we're asking to solve. So I just can set x squared minus 4 is equal to 3x. Now remember, every time they have the second power higher, you're going to bring everything to one side. And then you're going to try to see if you can factor it. So I have x squared minus 3x minus 4 is equal to 0. The signs are going to be opposite, right? So I have x plus and x minus. Factors of 4 that when I subtract, I get to 3, and that's 4 and 1. So because of the zero product property, either x plus 1 is equal to 0 or x minus 4 is equal to 0. So x is either equal to -1 or x is equal to +4. All right, so we're going to check that. Let's start with the 4. Now I just have to go and check my arguments, right? So I have 4 squared minus 4 is equal to 3 times 4. So this is x is equal to 4. That's what I'm checking right now. So I get 16 minus 4 is equal to 12, which is true. So that one's good. Let's try x is equal to -1. Now the thing I notice already with this 3x, I have 3 times -1, which would give me a negative number. And remember that argument has to be positive. So that value is not going to work. So our final answer for this problem is x is equal to 4. This x is equal to -1 is an extraneous solution, right? It worked in the problem. It's not that we solved it incorrectly or we made a mistake, but when we substitute it back in, it does not satisfy the original equation. Okay? All right, let's look at some inequalities. It's basically the same as the equation except for one little thing that's going to be different. Okay, so we'll see how we do. Okay, so again, x, I want my x on the left-hand side, and then is greater than or equal to, I'm just going to copy that sign as is, base 4 raised to the third power. So x is greater than or equal to 64. Now remember, this x, right, that argument has to be greater than 0, which it is, so I'm fine. So I'm going to write this as x such that x is greater than or equal to 64. That's my final answer right there. All right, let's take a look at number 6. So I have x is less than or equal to, my base is 2, and I'm raising it to the fourth power. 2 to the fourth is 16. Now, the one thing I have to be careful of, remember, we said x has to be greater than 0. So I can't do all the numbers that are less than or equal to 16. That would be 10 and 5, but it'd also be -2, -4. So I can't have all those values. So I do need to make some restrictions there. So x such that x is going to have to be between 0 and 16. It has to be greater than 0, so I'm not going to have an equal sign. My original problem was had an equal sign, so that's okay. Right? So somewhere between 0 and 16 will work for my solution. All right, let's take a look at number 7. Again, the logs are the same, so I have x plus 3 is greater than or equal to 2x plus 1. I'm going to bring my x to the other side, and I have negative x is greater than or equal to negative 2. I'll divide both sides by negative 1 and change the direction of my sign. So I have x is less than or equal to 2. All right, so that's one thing I have to worry about. Now let's go back to my original, to my arguments, right? So I also have x plus 3. I know that has to be greater than 0. So x has to be greater than negative 3. That's the other thing. That's the other thing that we need to worry about here. And let's look at another one. I have, again, 2x plus 1 also has to be greater than 0. So 2x is greater than negative 1. So x is greater than negative 1/2. So I have all these things I have to worry about. Now, I often say in these videos, when I was a kid, I hated the number line. But as I'm a teacher, it helps so much. So if it helps you, then go ahead and draw it. So I have a lot of values going on. Here's my 0. Here's 2. I have negative 1/2 there, and I have negative 3. Okay, so I need it to be less than or equal to 2. So it's going to be my closed circle. Now, it has to be greater than negative 1, and it also has to be greater than negative 3. In order to do both, I really need to pick this symbol right here, right? So I'm going to go, it's actually going to be between those values. Okay, so then I'm going to have between x such that negative 1/2 is less than x, which is less than or equal to 2. Okay? All right, let's look at our last one for today. Again, I have my bases are the same, so I have 4x minus 6 is greater than 2x plus 8. So I'm going to have 2x is greater than 14, so x is greater than 7, so that's 1. Now let's look at each of our arguments. 4x minus 6 must be greater than 0. So I have x is greater than 6 over 4, so x is greater than 3 over 2. The last thing we have to look at is this 2x plus 8. So 2x plus 8 has to also be greater than 0. So 2x is greater than negative 8. X is greater than negative 4. Now, we have all these greater than, right? X is greater than 7. And it has to also be greater than 3 over 2. It also has to be greater than negative 4. So in order for that to be true, we have to go with a higher value. So our final answer is x such that x is greater than 7. Okay, thanks so much for stopping by today. You have a good one.